These notes are on using the quadratic formula. So in class, you have discussed two different methods for deriving the quadratic formula. One using completing the square method, and the other using a method that is connected to the relationship between the vertex and the x-intercepts. Now that you've derived the quadratic formula, though, it also is important to know how to use it. So in your derivation, you have found that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to use the quadratic formula, therefore, I need to make sure that my equation is in standard form. So my ax squared plus bx plus c equals 0 form. And then I need to identify my a, b, and c. So in this problem, my a is 1, my b is negative 3, and my c is 2. So now it's a matter of plugging these numbers in correctly into this formula. So I have x equals negative of the b, which is negative 3, plus or minus the square root of b squared, so that's negative 3 squared, minus 4 times a times c, all over 2 times a. So the negative of negative 3 is positive 3, plus or minus the square root. Negative 3 squared is 9, minus 8, all over 2. 3 plus or minus the square root of 1 all over 2. 3 plus or minus 1 all over 2. And in this case, since I've simplified my square root, I know the square root of 1, I can actually get down to having this as two separate numbers. So I'm actually going to say that this is 3 plus 1 divided by 2, comma 3 minus 1 divided by 2, meaning that my x is either 2 or 1. Let's look at a second example. Again, just in part so that you can learn the quadratic formula, memorize it more quickly. I always start by writing the formula itself. That way, the process of writing it is helping me commit it to memory, so that you don't have to worry about knowing it or not knowing it for a test or a quiz. So first I wrote my formula. Second, I looked to find my a, b, and c. However, this is not yet written in standard form, so I'm going to have to get it equal to 0, which means I got to get rid of the negative 10 on the right-hand side. So I do that by adding 10 to both sides. So I now have my a equals negative 2, b equals 5, and c equals 10. So x equals negative b, so negative 5, plus or minus the square root of b squared, 5 squared, minus 4ac, all over 2a. I have negative 5 plus or minus the square root of 25 plus 80, all over negative 4. Negative 5 plus or minus the square root of 105 all over negative 4. Now 105 can be divided by 5, so let's see if that gives us a perfect square in there. And it doesn't. 105, the factors are 3, 7, and 5, and so I can't simplify that any further, and so I actually can leave my answer as x equals negative 5 plus or minus square root of 105 over negative 4. Now, if you wanted to, you could separate that out as two answers, negative 5 plus the square root of 105 over negative 4, and negative 5 minus the square root of 105 over negative 4. Either of these two answers is generally correct, and your teacher may have a preference for which form you write it in, but either is mathematically correct.